So next we will be learning about inverse Laplace transform. Okay, finding the inverse Laplace transform. Okay, inverse Laplace transform means they will give you the value of x of s. This will be given in the question, x of s, that is the Laplace transform will be given in the question, and from x of s you need to find your original time domain signal x of t. Okay, so this is called as inverse Laplace transform, that is finding the inverse from Laplace transform. Okay, so how will they find it means, in every Laplace transform the way of asking the question will always be in this format, that is we can represent this Laplace transform in this format, that is numerator by denominator. All Laplace transforms, okay, every question that they give you, they will always be in this format, that is they will give you a numerator by denominator function, numerator function of s and denominator function of s. Okay, so how to find the inverse Laplace transform from here? For that you need to consider the denominator of s. This is what you need to consider, the denominator of s. Depending on how the denominator of s looks like, you are going to find the value of x of t. Okay, you have already learned this in last semester, so we are just going to revise that again. Okay, so how do we do it is, the only method that you need to understand, the only method that we are going to apply here is the partial fraction method. Okay, partial fraction method. So what is this partial fraction method? It is this method in which we are splitting this denominator d of s. We are isolating or separating this d of s in many factors, and then we find the inverse Laplace transform of each and every factor. That's how we do this problem. Okay, that's one of the easiest method of finding the inverse Laplace transform, that is they separate this d of s into many factors. Okay, and how many factors, that depends on the denominator. Okay, so that means this d of s will be basically might be an equation or something. So what you're going to do is you're going to factorize that equation. Okay, you're going to make this into a many factors, or separate them into many poles, and then we are going to apply the Laplace transform to each and every pole. Okay, so for example, let's take for example that this d of s, this denominator d of s, we can represent it as in terms of s plus a into s plus b, s plus a into s plus b. So what I'm going to do, so how I am representing this, so in that case this x of s will be equal to n of s by s plus small letter a into s plus small letter b. Okay, so this is, so this is what you call as factorize, that is I am changing this equation into its factors, and then what I'm going to do is I'm going to separate these factors in this format. Okay, I separate these two factors, and then I apply my inverse Laplace transform to each and every factor. That's your final answer. Okay, that's what we do. So there are different, so depending on the denominator there are different approach of how to solve this problem. Okay, that is, first approach is, suppose if the denominator, this d of s, okay, suppose the first approach is that, suppose this d of s is having distinct poles. Distinct poles means there are no repeating poles and there are no any complex poles, nothing like that, just simple very easy poles like this. This is a distinct poles. Okay, so if d of s is a distinct poles, then all you need to understand is this is how you separate it. Okay, that's all. This is how you separate your factors. Okay, so for example, if I am saying that, suppose if x of s is s plus 4 by s plus 3 into s plus 2. Let's do this question. Okay, s plus 4 by s plus 3. So you can see here that d of s is given. Sometimes they can give this question in this format, or sometimes they will give like this. s square plus 5s plus 6. Okay, sometimes they will give this, these two are very same questions. Sometimes in the question paper they will give the question in this format, or they will give the question in this format. If they have given the question in this format, then you have to learn to factorize this equation into separate factors. You have to learn to separate this equation into many factors. Okay, you have to learn to do that. Okay, so in that case, if this is the type of question, then how can you separate the terms? How can you separate the factors? By separating. So here you can see there are two distinct poles or two distinct factors, so you can easily separate them in this format. That is a by s plus 3 plus b by s plus 2. This is how you separate them. Okay, see that this means that the denominator has two poles, so I am writing the two poles separately. Okay, this factor represents for this pole and this factor represents for this pole. Okay, so now how to find the value of a and b very easily? How to find the value of a and b very easily? That's a very, there's a equation for that. That is to find, suppose I want to find the value of a. Okay, a. So if I want to find the value of a, okay, first you look at the denominator of a. The denominator of a is s plus 3. So the equation for a is s plus 3 into x of s when s is equal to minus 3. Okay, you have understood how you got s is equal to minus 3 is. If I equate s plus 3 is equal to 0, then I will find, I can say that s is equal to minus 3. Okay, so how do I find a? By multiplying s plus 3 with this, or by multiplying s plus 3 with this. Now you can imagine what happens. Suppose if I multiply s plus 3 with this, what will happen? This s plus 3 and this denominator s plus 3 will be cancelled. So only these two terms are remaining. So that means the easy way of finding a, the easy way of finding a is that you look at the denominator s plus 3. So here the denominator is s plus 3. So you look at the denominator, and that denominator you should remove from your question. Simply remove the denominator. Keep everything as it is and then simply separate that denominator. So you will get s plus 4 by s plus 2. You see, this is x of s without s plus 3. Okay, then you substitute the value of s plus 3 as, you substitute the value of s as minus 3. Okay, so that means the value of a is 4 minus 3 is 1 by minus 3 plus 2 is minus 1. So which means a is equal to minus 1. Okay, likewise if you want to find the value of b, look at the denominator of b. The denominator of b is s plus 2. So what you're going to do is remove s plus 2 from here. Simply remove s plus 2 from here. So you will have s plus 4 by s plus 3. Okay, and then substitute the value of s as minus 2, because s plus 2 is equal to 0, so therefore s is equal to minus 2. So substitute the value of s as minus 2. So you will get 4 minus 2, 2 by minus 2 plus 3 is 1. So the answer is equal to 2. Okay, this is how you find the value. Understood? This is how you find the value of a and b. So finally, so if you want to find the inverse, now if you want to find the inverse, so what is the answer? So this is, so x of s, you have found that x of s is equal to minus 3 by s plus 3 minus 1, sorry, minus 1 by s plus 3 plus 2 by s plus 2, right? So therefore your x of t is nothing but the inverse Laplace transform. This is how you apply inverse Laplace transform of x of s, which is nothing but the Laplace inverse of minus 1 by s plus 3 plus Laplace inverse of 2 by s plus 2. Okay, I can take the constant outside, minus 1 into Laplace inverse of 1 by s plus 3 plus 2 into Laplace inverse of s plus 2. Sorry, Laplace inverse of 1 by s plus 2. Okay, so we know the Laplace inverse of 1 by s plus 3. e raised to minus 3t into u of t. Okay, plus, and you know the Laplace transform of 1 by s plus 2, that is 2 into e raised to minus 2t u of t. See, this is how you do the problems. This is a very simple question. Here the given fraction is a distinct poles. So this is first approach. Okay, the second approach is, suppose if your d of s is having multiple poles. Multiple poles means multiple same poles. For example, okay, suppose if it will be somewhat given in this formula. For example, let x of s, okay, I'm going to change the question. It is s plus 4 by s plus 3 the whole square into s plus 2. Okay, suppose this question is in this format. Okay, so in that case, you have to see, this is called as multiple poles. See, means totally how many poles are there? There are 3 poles. One pole is at s is equal to minus 2 and 2 poles at s is equal to minus 3. That means the poles are at s is equal to minus 2, s is equal to minus 3 and s is equal to minus 3. See, 2 s is equal to minus 3 because there are 2 factors. So therefore 2 s is equal to minus. This is called as multiple poles. So suppose if your denominator is having multiple poles, then how do you partial fraction this? How do you separate this? Separating this is by, first you look at the factors. Okay, so here there are 3 factors, s plus 3 the whole square. That means here there are 2 factors and this is 1 factor. So you separate this like this: a by s plus 3 plus b by s plus 3 the whole square plus c by s plus 2. Okay, this is how you separate them. There are 3 factors, so therefore there should be 3 terms: a by s plus 3 plus b by s plus 3 the whole square plus c by s plus 2. Okay, so now how you are going to find the value of a, b and c? How you are going to find the value of a, b and c? Okay, so how to find the value is that first in this question you look at the denominator. Okay, so here the denominator is s plus 3 the whole square into s plus 2. Okay, if you look over here, this factor is complete because the denominator has s plus 2 and then one factor like that is over here, s plus 2. So this factor is complete. Okay, now look at the value of the second one over here. Here the denominator is s plus 3 the whole square. So it means this also the factor is complete because the denominator here is s plus 3 the whole square. So that means there's s plus 3 whole square over here. So these 2 factors are complete. Now look at the first factor, a by s plus 3. In this factor, this is incomplete. Incomplete means here you need s plus 3 the whole square, but only s plus 3 is over here. That means another s plus 3 is missing. Okay, so these 2 factors are complete, right? So in that case, that means these 2 are distinct factors. That's what I meant. Multiple poles means this is the multiple pole. Distinct poles, last case you have learned distinct poles. That means these 2 are the distinct poles, and out of 2 distinct poles, 1 pole is repeating. So these 2 distinct poles has these 2 distinct factors for B and C. So for B and C, you can find the answer how you found in the last case. That is the value of, suppose I will start with C. I want to find the value of C. So C is nothing but here the factor is s plus 2. So simply remove s plus 2 from here. I can say that this is s plus 4 by s plus 3 the whole square. That is after when I remove s plus 2. Okay, if the denominator is s plus 2, so I am going to remove that factor s plus 2. So s plus 4 by s plus 3 the whole square, and then substitute the value of s as s plus 2 is equal to 0. So substitute the value of s as minus 2. This is how you find the value of C. So immediately I can find the value of C. Here it is 4 minus 2. 4 minus 2 is 2, and here is 3 minus 2 is 1. 1 square is 1. So you will get the answer as 2. Okay. Now after this, same way you can immediately find the value of B, because B is having the denominator of B is having the highest power. Okay. So you can find the value of B. So how do you find the value of B? Simply remove the factor. Here the denominator is s plus 3 the whole square. So remove that factor, s plus 3 whole square. Remove that factor and take the remaining terms, s plus 4 by s plus 2. Then you substitute the value of s. Here s plus 3 is equal to 0, so s is equal to minus 3. So substitute the value of ss minus 3. So you will get the answer as, here 4 minus 3 is 1 and minus 3 plus 2 is minus 1. So 1 by minus 1 is minus 1. Okay, this is how you find the value of b. Now how to find the value of a? Okay, hey, you cannot apply this approach. Why? Because here s plus 3, even if I remove s plus 3, another s plus 3 is left behind. So I cannot apply this approach to find the value of a. Okay, but it's very easy. How to find the value of a is, here you can see that the denominator of a over here is 1, here the denominator of b over here is 2. Okay, the denominator power of here is 2 and the power of the denominator of here is 1. Okay, so what you're going to do is simply differentiate this one time. Simply differentiate this one time. That is, the value of a is nothing but differentiating this one time and then substitute the value of ss minus 3. This is how you find the value of s, the shortcut method of finding the value of s. So which is nothing but, here this is u by v, so v into du, du is 1, right? This, if you differentiate, this is 1 minus u into dv, u is s plus 4 into dv, here dv is 1 by v square, that is s plus 2 the whole square. This is nothing but, here s and s is cancelled, 2 minus 4 is minus 2, so minus 2 by s plus 2 the whole square. Minus 2 by s plus 2 the whole square. Now substitute the value s is equal to minus 3. Now substitute the value of s is equal to minus 3. Okay. Substitute the value of s is equal to minus 3. What if I substitute, what will I get? Minus 2 by, here it is minus 3 plus 2. Minus 3 plus 2 is minus 1. Minus 1 the whole square is 1. So the answer is minus 2. See, this is how you find it. Okay, so when you are using multiple poles, if you are using multiple poles, how do you find it is that you separate that factors. Here, how many factors of s plus 3 are there? 2 factors. So separate them into 2 factors. Okay, in increasing order. So write them in the increasing order. Plus c by s plus 2. Okay, and then what you do is, first you find the value of the complete poles. So these 2 factors are complete. See, because s plus 2, s plus 2, s plus 3 the whole square, s plus 3 the whole square. So these 2 factors you can find it just like how you found before. So c s plus 4 by s plus 3 whole square. Here denominator is s plus 2, so remove s plus 2. So in that case you will get this factor, then you substitute ss minus 2, you will get the value of c. Likewise for b also, here s plus 3 the whole square, so the factor is complete. So remove s plus 3 the whole square from here, so it will be s plus 4 by s plus 2, then substitute the value of ss minus 3, because s plus 3 is equal to 0, so substitute the value of ss minus 3, you will get the value of b. Then what do you have, when you are going to find the value of s, so when you are going to find the value of a, simply differentiate the equation for b. Understood? Differentiate the equation for b and then substitute the value of ss minus 3. That's all. Then you can find the value of a. Okay, this is how you do the problem. Okay, this is when denominator of s is having multiple poles. Okay, if it's having multiple poles. All right, so now another approach is when d of s is in this form, that is, how to write it in this form. Suppose d of s is in the form, this is the next approach, that is, if d of s is s square plus a square. Okay, suppose if this is the form, if d of s is in this form, s square plus a square, then how do you do this problem? Okay, this is also a very easy method. very easy method. Okay, that is, suppose let me write for example that x of s is equal to s plus 4 by s plus 4 the whole square. Okay, let me change question. S plus 3, make it s plus 3. S plus 3 by s plus 4 the whole square. No, sorry. S plus 3 by s square plus 4 square. Okay, make it 2 square. Okay, suppose if they give the approach like this, s plus 3 by s plus square plus 2 square. Okay, so how do you going to solve if they have asked these kind of question? So in that case, what you need to do is you should understand one thing, that is you should understand that a square plus b square, okay, is nothing but a plus jb into a minus jb. Always, we know this already, right? If you cross multiply this, always it comes back in this form. Alright, a square plus b square. In that case, you can separate this. We know that if the question was like this, then you can factorize it by this method. That is, a square minus b square is a plus b into a minus b. But suppose if the question was a square plus b square, then you can factorize like this. That is, you can factorize it as a plus jb into a minus jb. This is nothing but a square plus b square. Okay, so that means this is nothing but complex roots. So if you are having complex roots, then how do you solve this question? Very easy. So suppose, for example, let me try this question over here. Suppose x of s is equal to s plus 3 by s square plus 4. Okay, if this is assume that this is your question. So what you're going to do is you are going to separate this into two factors, into two complex values. So you are having complex poles. That's all. That's the only difference. You are going to have complex poles. The rest is same. So here you will get s square plus 2 square. That means if I am going to factorize this, it will be like s plus 3 by s plus 2j into s minus 2j. S plus 2j into s minus 2j. This is how you are going to separate the factors. Then after that you write a by s plus 2j plus b by s minus 2j. Okay, now you can assume that this is a distinct poles, just like the case 1, the first case that you have studied, distinct poles. You can assume that in this format also. Okay, and actually this is much more easier, because when you are doing this problem, you don't need to find both a and b. You don't have to find both a and b. You need to find only a. Just simply find the value of a. Okay, and when you are going to find the value of b, when you are going to find the value of b is nothing but complex conjugate of a. That's all. Okay, so you need to find only a. Just simply find the value of a or b. Find any one of them. Find any one of the coefficient. Then finally, in order to write the other coefficient, simply take the conjugate of your first coefficient. That's all. That's how you're going to find the value. Okay, for example, let's do this problem over here. So here I can say that a is equal to, so here the denominator is s plus 2j. So I'm going to remove s plus 2j. So it will be s plus 3 by s minus 2j. S plus 3 by s minus 2j. Okay, and then substitute the value of s as here s plus 2j is equal to 0. So s is equal to minus 2j. So s is equal to minus 2j. Okay, so now this is the equation for finding a. So that means I'm going to substitute s as here s is minus 2j. So the numerator will become minus 2j plus 3 by, here it will be minus 2j, it will be minus 4j, okay, or this is nothing but 3 minus 2j by 4j. Okay, now what I'm going to do is I'm going to make this into a proper format, right? So I'm going to multiply the denominator and numerator by 4j. Okay, multiplying the numerator and denominator by 4j. So I can remove this j at the denominator. So or I can simply multiply these two by j itself. That's more than enough. So this will become here, if I multiply here, this will become minus 2j into j. J into j is minus 1, minus 1, minus, so it will be 2 plus 3j, right? This will become 2 plus 3j by, if I multiply this into j, it will be minus 4. So this is nothing but minus 2 minus 3j by 4. This is nothing but minus 2 by minus 3j by 4. This is the value of A. So now to find the value of B, simply substitute the value of B as the conjugate of this. That's all. B is nothing but the conjugate of this. So that means B will be minus 2 plus 3j by 4. Okay. Then you can substitute the equation over here and find the inverse as usual. Okay. This is another approach. Now one more approach is there. Another approach is, suppose if it is given in a quadratic equation style. Suppose if d of s is in a quadratic equation style. That is what I meant is, suppose d of s is given in this format. For example, s square plus as plus b. Then how do you factorize this? Okay, so how do you find it? This is also very easy. In order to find the factorization, first you have to look at the equation very closely and then concentrate on the first two terms. Okay, for example, let me take an example. Suppose if I'm taking a question, s square plus 2s plus 10. Okay, let this be a d of s. Okay, let this be a d of s. Let the question be like this: x of s is equal to s plus 4 by s square plus 2s plus 10. Okay, so how you are going to find the factorization of this? How you are going to factorize this? This is nothing but a quantity equation, right? So you cannot factorize it into two separate factors simply by looking at it. No, you cannot do that. So what you're going to do is, you are going to separate this in another format. And how you separate it is, simply look at the first two questions, the first two terms. Here it is given s square plus 2s. Okay, you need to familiarize with the equation, that is a plus b the whole square is a square plus 2ab plus b square. A square plus 2ab plus b square. So that's what I said. You need to look at the first two terms. Simply look at the first two terms. Okay, here it is 2s. Here you can see it is 2s. So s square plus 2s, right? So what I am going to do is, I know that s square plus 2s plus 1. I know this. S square plus 2s plus 1 is s plus 1 the whole square, right? So I'm going to substitute this over here. So that means my denominator will become s plus 4 by s plus 1, or let me write it like this, that is s plus 4 by s square plus 2s plus 1 plus 9. Okay, I separated this 10 into 1 and 9. 1 plus 9. Why? Because I can use this 1 for this equation, s plus 1 the whole square and 9. So this is nothing but s plus 4 by s plus 1 the whole square plus 9. 9 is nothing but 3 square. So this is nothing but s plus 4 by s plus 1 the whole square plus 3 square. Right? So you can separate the factors as s plus 4 by, this will become s plus 1 plus 3j and s plus 1 minus 3j. See? So you have changed this question into distinct poles, your case 1 case. So this, you have made this into distinct poles. So now you can apply the equation a by s plus 1 plus 3j plus b by s plus 1 minus 3j, and then you can find the value of a and b just like how you found it before. Yes, this is how you find the equation. Okay, very easy format. Okay, so here you can, so you should learn to distinguish this. You need to separate this. Okay, so this is one way of separating. Another way, so for example, if it is s square plus 6s plus 45, s square plus 6s plus 45, how you going to separate this? Okay, so you have to look at the first two terms. S square plus 6s, 6 divided by 2 is 3, right? 6 divided by 2 is 3. So suppose I want to find s plus 3 the whole square. So what is s plus 3 the whole square? S square plus 6s plus 9. See, s square plus 6s plus 9. The first two terms are the same. First two terms are the same. So what is missing is 9. 9 is missing. So here I can take the 9 from here, right? I can take the 9 from here. So this will become s square plus 6s plus 9 plus 45 is nothing but 36, right? So this is nothing but s plus 3 the whole square plus 6 square. See? So if your denominator is like this, I can factorize like this. So it will become s plus 3 plus 6j and s plus 3 minus 6j. Okay? So this is how you can do the second question. Alright? So these are how the denominator can come in the form of distinct poles. It can come in the form of distinct poles, or it can come in the form of multiple poles, or it can come in the form of complex poles. That is, you can separate this into two complex factors. So complex poles, or you can come in the form of a quadratic equation. That is also somewhat in a complex poles. You can separate them. This is how the different types of denominator graphs. So which denominator, so looking at the denominator, you need to find the inverse. Okay. Now, one more thing that you also need to understand, one of the most important thing that you need to understand is you need to find whether your given question is a right-sided signal or a left-sided signal. That is also a very important. This was not there in your last semester. That's the only difference between this semester and last semester. Last semester, you don't need to find whether it is right-sided poles or left-sided poles. You can simply assume that everything is right-sided poles. That's why you're multiplying it by u of t. Right? But if suppose they might give you the question such a way that that it is a left-sided pole, I'll tell you how you find out whether it is right-sided or left-sided. Okay. If you remember that shortcut video that I said before, that is when you are finding the Laplace transform, when you are going to find the Laplace transform of, suppose I'm going to find the Laplace transform of e raised to minus 80 into u of t. Okay, I want to find the Laplace transform of this. Okay, so here the Laplace transform of this is 1 by s plus a, 1 by s plus a. Okay, so this is the Laplace transform of this. So this is a right-sided signal. Right, this is a right-sided signal. Now I have also told you here right-sided signal means the real part of s is greater than minus a. That is why this is a real part of s. How do I know this is a right-sided signal? Because it is multiplied by u of t. Since it is multiplied by u of t, that is why my real part looks like this. Okay. In the same way, suppose I'm going to find, suppose if I want to find the Laplace transform of e raised to minus 80 into u of minus t. Now I have made this an left-sided signal. U of minus, I'm multiplying this with e raised to minus t, so this becomes a left-sided signal. So my Laplace transform will be negative of this, minus 1 by s plus a. Laplace transform will be minus 1 by s plus a, negative of this answer, and your real part of s, according to the properties of ROC, the real part of s is given by real part of s less than minus a. Right? Why it is less than minus a? Because it is a left-sided signal. How did I know it's a left-sided signal? Because the question is multiplied with u of minus t. So u of minus t, since u of minus t is left-sided, then the real part of s becomes less than minus a. If it is right-sided, greater than minus a. If it is left-sided, less than minus a. Okay. Now what happens if, now look at this, okay. What happens if your Laplace transform is minus of e raised to minus 80 u of minus t? What are you going to find the Laplace transform of this? if you're going to find the Laplace transform of this, then your Laplace transform will be 1 by s plus a itself. It will be 1 by s plus a itself. And since this is a left sided signal, your real part is as usual, it will be less than minus a. It will be less than minus a. So if you look over here very carefully, you can see that the Laplace transform of this and the Laplace transform of this are one and the same. Look at the function. Here it is u of minus t. Here it is u of t. Here also there is a minus sign. Here there is no minus sign. So if I am going to find the Laplace transform of this, and if I am going to find the Laplace transform of this, then I know that my Laplace transform is same. So what is different? This is different. The ROC is different. Since this is a right-sided signal, the real part of s is greater than minus a. Since this is a left-sided signal, the real part of s is less than minus a. Okay? So now in your given question, so this is how you have to remember. So if it is a left-sided signal, what you need to do is you have to multiply your signal with